Hello everybody. In today's video, let us discuss about the practice bits related to current. In three parts I am doing this video. In first part we will discuss about current, potential difference, electromotive force and Ohm's law. So current. Now first, based on current, the positive or negative particles present in the circuit we call charge. Amount of charge flowing across any cross section of conductor we call it as current, or we can also call it as electric current. Or in other words, current can also be defined as flow of electrons. We define as current. Now next, in rainy seasons we will see lightning, no? So lightning means nothing but an electric discharge between the two clouds or cloud and earth. So this lightning is the example for evidence of motion of charges in atmosphere. Now substances transfer the charge we call conductors. If they do not transfer the charge, we call it as non-conductors or insulators. Drude and Lawrence said conductors like metal contains electrons and positive ions. The arrangement of positive ions we call lattice. Mathematical formula for current: I equal to Q by T, charge by time. So charge flowing per unit time we will say. Units for current are ampere. 1 ampere is equal to charge in coulomb, time in second, 1 coulomb by 1 second. The electrons moving in conductor move with a constant average speed. Then such speed we call drift speed or drift velocity. The electrons in conductor move with constant average speed, and this speed we call drift speed or drift velocity. And the formula for drift velocity is I by NQA, where I is the current, N number of charges, Q charge of the charges, A is the area of cross section. Right? Now next, charges at rest. The study of physics dealing with charges at rest we call static electricity. The study of physics dealing with charges in motion we call current electricity. The region or space surrounded by effect of unit positive charge we call electric field. Now here positive charge is there. Now the effect of these charges spreaded up to this particular region. So this complete region or space we call electric field, and these we call electric flux lines or electric field lines. They start from positive charge and travels towards the negative charges. Now next, conventional current direction is positive to negative. Now what is field line means? Now for example, if we think the charge is moving from here, again came up to here, here, here in such a way. If we go on joining this, we get a straight line. So that imaginary line drawn in electric field along which unit positive charge move, we call it as electric flux lines. The mathematical formula for electric flux lines is integral E dot ds, where E is the parallel component of electric field, ds is the area. Now it is a vector quantity, so the magnitude is taken equivalent to, now if we take any cross sectional area perpendicular to the flow of electric flux lines, then how many lines flowing through it gives the magnitude of electric field, and the direction if we go on drawing a tangent on each and every point on the electric field, that tangent drawn at every point on flux line gives the direction of electric field. Right? Next, a simple circuit means it consists of source of electric energy, devices which utilizes it, and connecting wires. Now tap key makes or breaks the electric circuit. So ammeter measures the current. Now see the symbolic representation of some electric components. Cell or battery, both are same. Okay, cell or battery. Ammeter, voltmeter, rheostat, resistor, capacitor, inductor, transformer. Some of the components symbolic representation. Alright. Now next, so in filaments, in incandescent bulbs, as a filament we will use tungsten, important bit. So filaments used in incandescent bulbs, tungsten. So now let us move to potential difference. So now when ends of conducting wire are connected to the terminals of battery, an electric field is set up in the conductor. This field exerts the force on charge, that is electron. Alright, here I am explaining what is potential difference. So I am giving some knowledge regarding the potential difference itself only. So you take a battery, connect the ends of conducting wire on either side of that terminals of battery. Then if electric field is established in the conductor, this field exerts some force on charges. Means it is showing that electric field is doing some work to move the charges. Right? So such work done is given as FEL. Okay, sorry, electric force into distance. Electric force into distance. Right? Now work done by electric force on unit charge. Work done means force into distance. Here electric force we took. Right? L is the length of that conductor. Through that length only the charges are moving. So we took L equivalent to the distance. Now work done by electric force on unit charge, W by Q, that is FEL by Q. So work done by electric force on unit positive charge to move it from one point to other point, that is A to B, we define as potential difference. So what is potential difference? We denote with letter V. Work done on unit positive charge to move it from one point to other point, or to bring it from infinity to the reference point. In such a way also we can define from infinity to the reference point. We define as potential difference. Units are volts. 1 volt equal to W by Q, no, 1 joule by 1 coulomb. Battery or cell maintains constant potential difference till they are completely discharged. Okay, now let us see a small explanation regarding battery. So battery, it consists of two metal plates we call electrodes and a chemical we call it as electrolyte. This electrolyte exerts certain force on ions, makes them to move. So they accumulate on these two plates. One plate on which positive charges are accumulated, we call it as anode. Other plate on which negative ions are accumulated, we call cathode. Ions in motion also experiences electric force, and this electric force will be opposite to the chemical force. When electric force and chemical force are balanced, there will be no motion of charges. There will be no motion of charges. Right? So now our battery is ready. Right? Our battery is ready, which we purchase in market. In such a way we will prepare the batteries. Now when conducting wire is connected to the terminals of battery, potential difference is created at the ends of conductor. Okay, work done by electric force to move a unit positive charge only we call potential difference. Now next, electromotive force. Actually both are same, but here work is done by electric force to move the unit positive charge. Here work is done by chemical force to move the unit positive charge we call electromotive force. Voltmeter is used to measure the potential difference or electromotive force. Now next, let us move for Ohm's law. Ohm's law says that potential difference between the ends of conductor is directly proportional to the current passing through it at constant temperature. V equal to IR, where R is the proportionality constant, we call it as resistance. And units of resistance is ohm. So 1 ohm, here if we write IR equal to V by I, 1 ohm equal to 1 volt by 1 ampere. So materials which obey Ohm's law we call ohmic conductors, which does not obey Ohm's law we call non-ohmic conductors. The VI graph for ohmic conductor will be a straight line. This Ohm's law is not applicable for gaseous conductors, semiconductors. Now here one problem is given. If 2J of work is done in carrying 2 coulomb of positive charge from one point to other point, find the potential difference. Potential difference means work per unit charge. 2 joules by 2 coulomb, that is equal to 1 volt. So thank you for watching my video. If you like my video, share it, subscribe it. Thank you.